So far, we have explored the single responsibility principle and the open closed principle. The single responsibility principle taught us to give each class one and only one responsibility. And the open closed principle showed us how to make our system extensible without changing our existing code. Today we will explore the third principle, that is the Liskov Substitution Principle or the LSP. The Liskov Substitution Principle states that the objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. Sounds abstract, right? So let me break it down for you. In simple terms, if you have a base class and a subclass, you should be able to use the subclass wherever the base class is expected without breaking the program. And now to understand it better, let's return to our FTS hotel management system for a real world example. Our hotel has a loyalty program with two types of customers, the regular guests and the premium members. Regular guests are those who book rooms occasionally and pay the standard rate, whereas the premium members are those who enjoys a flat 20% discount on every booking. Both regular guests and premium members are the customers, but premium members have some special privileges like, let's say, 20% discount or not standing in the queue, etc. So now let's design this in code while ensuring we follow the Liskov substitution principle. Now, we are going to start by creating a base class called customer to represent all the customers. So let's just simply add a class, customer, and inside of it, let's create a method, I'm marking it virtual, get room rate, and it accepts a double base rate and return base rate. Get room rate method here is calculating the amount a customer has to pay for a room. For regular customer, it simply returns the base rate. Now, let's create a subclass premium member for premium members, those who get a 20% discount. Let's just simply add a class, premium member, and extend customer. And inside, let's override, it was double, get room rate. And now, since the premium members are supposed to get 20% off, let's return base rate product with 0.8, which is 20% discount. This class is basically extending the functionality of the customer while keeping the behavior consistent. Now let's see how we can use these classes in our system such that the hotel can handle both regular guests and the premium members seamlessly. Let's go to the main method and declare base rate $100. So for regular customer, regular guest, new customer, let's console write line regular guest room rate in dollars. Okay, regular guest get room rate, and let's pass in the base rate. Similarly, for the premium members, let's create customer premium member equals new premium member, and let's console write line premium room rate, again it was in dollar, premium member get room rate with the base rate again. Now in this example, we are creating the regular guest object of class customer, that is the base class, and then we are creating the premium member object of the premium member subclass. And we can also see that both the objects are treated as customer objects and the program works without any issues. So the key here is that we can substitute the premium member object wherever the customer object is expected without breaking the functionality. Now, let's try to understand what happens if we don't follow the Liskov substitution principle. Let's say for the corporate tie-ups, FTS Hotel decided to introduce another type of customers, the corporate customers. And for that, we need to introduce another subclass, corporate member, which is going to extend customer. And while overriding the getRoomRate method, let's say we made a mistake in the design, and for that, let's throw an error here. Not implemented exception, and let's just throw any error message. Let's say corporate members must use a corporate account. Here, instead of providing a valid implementation for getRoomRate, the corporate member class is throwing an exception. So basically, if we try to use this subclass in place of a customer, the program is definitely going to break. Let's see that in action. Let's go to the main method and copy this section. Let's rename it to corporate member here also, and in the right line, corporate member and corporate member here. Now since we are returning an exception from this method, this program is definitely going to fail, and hence we are violating the LSP. So now let's try to fix the design, and to fix that, we should ensure that all the subclasses provide meaningful implementation that aligns with the base class's behavior. So let's just return a valid value from here. Let's say base rate, and let's say for the corporate members we are providing a 30% discount, so 0.7 here. Now the corporate member class is going to behave consistently with the customer class, and we can substitute it without any issues. To summarize, the Liskov Substitution Principle ensures that our code remains flexible, consistent, and easy to maintain by allowing the subclasses to replace the base classes seamlessly. That's it for the LSP lesson. In the next video, we will explore the interface segregation principle and learn how to design interfaces that are tailored to specific client needs. Stay tuned.